y'all. Today we're going to take a look at rationalizing the denominator. So that's going to be our goal today, rationalizing the denominator. What that means is in the bottom of your fraction, you can't have a square root, you can't have a negative exponent. We want the number in the bottom of our square root to be positive exponent. So today I'm going to show you how to rationalize your denominator so that your denominator does not have a square root in it, like this one here, like that one here, like this one down here. We don't want it to have a square root in the denominator. So I'm going to show you how to rationalize the denominator. So you don't have to write this down in the red, just trying to give you a little backstory about what we're doing here. So next week, we're going to be getting into some special ratios, 45, 45, 90-degree triangle, a 30, 60, 90-degree triangle. And this is going to be one of our ratios that are in it. And we're going to want to solve this equation for x. So the square root of 3 times x. We know the opposite of multiplying is to divide. So if I divide, I get this, right? So the square roots cancel, and x equals 10 over the square root of 3. Now, this is not the most simplified answer. 10 divided by the square root of 3. That is not the most simplified answer. I'm going to go through and show you how to simplify this because this is actually the very first problem that we're going to do together. So the process that we do is called rationalizing the denominator. Right now, even though it's in square root form, this square root is actually 3 to the 1/2 power. We don't want fractional exponents or negative numbers in our denominator as far as the exponent goes. So we're going to multiply by something so that when I add it together, it gives me a whole number. So 1, 2, 3, 4, 5, etc. So that process is called rationalizing the denominator. It does get a little involved, but we're not going to get way up there. In other math classes, we'll get way up there. We're just going to do some basic rationalizing the denominator, just enough for us to build up on this skill and use it for what we're doing next week. All right, so the first one, rationalizing the denominator. So we have 10 divided by the square root of 3. We can't have this square root in the bottom, so we're going to multiply both the top and the bottom by the square root of 3. And you'll see why we're going to do that in just a minute. So we're trying to get the square roots to cancel out. So on top, 10 times the square root of 3, we can't do anything with that. So we're going to leave it as 10 square root 3. One's a number, one has a square root. I'm just going to write them right beside each other, no different than like 5 times x or 3 times x. So 10 times the square root of 3. On the bottom, the square root of 3 times the square root of 3 becomes the square root of 9. 9 is a perfect square number, which is good. That's what we're trying to get to. The square root of 9 is 3. So our final answer, my numerator, is 10 times the square root of 3. And the square root of 9 is 3. And this is our final answer. So 10 square roots of 3 divided by 3. So we started up here at the top. We rationalized it. That's a new term for today. And it gave us 10 square roots of 3 times 3. All right, next, number 2. I got the square root of 2. So I'm going to multiply both the top and the bottom by the square root of 2. This is a number. This is a square root. You just put them beside each other. So 1 square root of 2. The square root of 2 times the square root of 2 gives me the square root of 4. And in just a minute, I'll show you a shortcut here. And the square root of 4, again, is a perfect square number. The square root of 4 is the number 2. So my final answer is the square root of 2 over 2. Now, hopefully you're noticing here, square root of 3 times the square root of 3 gave us 3. The square root of 2 times the square root of 2 gives us 2. That will always be the case. Anytime you multiply by the same thing as far as square roots goes, you'll get whatever number is on the inside. So the square root of 5 times the square root of 5 is 5. The square root of 7 times the square root of 7 is 7. So you'll get whatever number is underneath the square root. And we'll practice a little shortcut with number 3. So for number 3, I got 14 divided by the square root of 7. I'm going to multiply both the top and the bottom by the square root of 7. So on top, number, square root, just write them beside each other. So 14 over the square root of 7. Let's use our shortcut here. The square root of 7 times the square root of 7, the square roots are going to cancel, and we're left with the number 7. If you need to do the additional step where you get the perfect square number, no problem. But you should know maybe after, maybe do more than 2 of them. Maybe you'll get used to it. So the square root of 7 times the square root of 7 is just 7. And 14 divided by 7, I can simplify that. So 14 divided by 7 can be reduced. So my final answer is 2 square root 7. That is our final answer. And we're going to do some more of these. Just make sure you pause the video if I'm going too fast. Write your notes and things like that. The other 2 that we did could not be simplified, but this 14 and the 7 can be simplified. So if you can break it down, break it down. Right. So that's number 3. Number 4. Number 4, I want to simplify the square root of 2 over the square root of 5. And then we'll try another one. Mixing it up a little bit. Let's do 1 over 2 square root of 3. And let me give you one more before we go off and work on today's assignment. Number 6 is going to be 5 over 2 times the square root of 6. All right, so these are going to be our last 3 problems, so that you have 6 example problems for you to look at. All right, let's start with number 4. Rationalize it. So it's always focusing on the denominator. So whatever the denominator is, for right now, for our number purposes, we're just going to take the number. So multiply the top and bottom by the square root of 5. The square root of 2 times the square root of 5 is the square root of 10. We're going to use our shortcut on the bottom. Square root of 5 times the square root of 5. The 5s are going to cancel. We're left with 5. Ta-da! That is our final answer. Again, if you need that intermediate step, there is nothing wrong with that. The square root of 5 times the square root of 5 is the square root of 25. And the square root of 25 gives us 5. Problem 5, a lot of 5s there. So problem 5, we're going to multiply top and bottom by 2 square roots of 3. 1 times anything is itself. So that gives me 2 times the square root of 3. 2 times 2 is 4. And I'm going to use the shortcut. The square root of 3 times the square root of 3 is 3. So again, the square root of 3 times the square root of 3, the square roots cancels. That gives me 3. So on top, I have 2 square root of 3. And on the bottom, my denominator, 4 times 3 is 12. Now we are not finished. I need to simplify this fraction. 2 over 12 reduces to 1 over 6. So 2 12ths reduces to 1 6. So my final answer is the square root of 3 over 6. And that is our final answer. All right, last one. On number 6, multiply the top and bottom by 2 square roots of 6 over 2 square roots of 6. 5 times 2 is 10. Bring down the square root. 2 times 2 is 4. The square root of 6 times the square root of 6 is 6. Okay. So this gives me 10 square root 6. 4 times 6 is 24. Reduce with any fractions, not just in rationalizing with any fractions. So 10 over 24 reduces to 5 twelfths. So 10 over 24, that's a fraction that reduces to 5 over 12. And that is our final answer. Okay. So again, we're using this because next week we're going to be rationalizing the denominator occasionally when we get into the special right triangles that I'll teach you about next week. And so these are some examples for you. Now you can go do your Canvas assignment.